Here we have the formula for incremental gain from acquisition. In finance, we're always looking for incremental values. In other words, the values that will change as a result of undertaking a project. And an acquisition is a project basically just like buying a machine or building a factory. And so we want to look at the incremental gain. And so that's what this delta V is. Delta in science and engineering and mathematics is change. V is value, so that's the change in the value that results from this acquisition. V sub AB is the value of the merged firm. I will note that this value of AB assumes it is an all-stock deal. We have to say that because when we do a cash deal, some of the cash leaves the firm and goes with the target shareholders who are no longer participating in the new firm. But it's fairly easy to think about this right now. It's just a stock deal. V sub A is the standalone value of A, which is the firm that is doing the acquiring. And V sub B is the standalone value of the target firm, the firm which is being bought. Now, what can we do with this from an algebra perspective? Well, the first thing we could do is distribute this negative. Now we can solve for any of these four variables. Let's start by looking for the value of the merged firm. We know that we must add V sub A and V sub B to both sides. And so I've flopped things here. When I add V sub A and V sub B, those cancel out. They wind up on the other side with delta V. In other words, the value of the merged firm is equal to the standalone value of A plus the standalone value of B plus this incremental gain. Before the merger, these firms were only worth V sub A plus V sub B. Now they are worth V sub A plus V sub B plus delta V. If delta V is positive, then this is a good merger. In other words, it's creating value. But if it is delta V is negative, then we see that this actually destroys value and would be a bad idea. Let's see what else we can do here. How about we solve it for V sub B? It's going to be the value of the merged firm minus V sub A minus delta V. And similarly, we could solve it for V sub A is the value of the merged firm minus V sub B minus delta V. And so there we have solved this for every single variable in the equation. Now let's take a look at the maximum that A should pay for B. At the very most, they should be willing to pay the standalone value of B plus the entire incremental gain. And we call this VB star. Now this is actually a little misleading. I don't think they should pay that much because when they do so, this entire incremental gain of the acquisition goes to the target shareholders. And after all, the goal of financial management is to maximize the wealth of your current shareholders. For firm A, the current shareholders do not include the target shareholders, and so they should be trying to get some of this delta V for themselves, but I digress. So we've got also from our previous slide, delta V is equal to V sub AB minus V sub A minus V sub B. And we're going to see that we can do some substitution. But first, let's just mess around with this first equation and solve for these other things. So for instance, what if we were looking for delta V? From this first equation, we could say that it is VB star minus V sub B. We could also solve for the standalone value of B if we somehow knew VB star and delta V. But let's do something a little more exciting. What if we were to substitute this delta V into this equation? What could we come up with then? VB star is equal to V sub B plus, now we need to substitute in V sub AB minus V sub A minus V sub B. And so we can see that our V sub B's cancel, and what we would be left with would be V B star is equal to V sub AB minus V sub A. So if you knew what the value of the merged firm was going to be and you knew the standalone value of A, you could figure out what is the most they should absolutely pay for this acquisition. Let's talk about the net present value of an acquisition. Recalling that the goal of financial management is to maximize the wealth of our current shareholders, this NPV is the net present value to the shareholders of firm A, because this is a project being undertaken by firm A. And this NPV is equal to VB star, which we just talked about, minus the cost of firm A to acquire firm B. And so if this cost is lower than VB star, it is a positive net present value project. And we should accept all positive net present value projects as those add to the wealth of our shareholders. However, if this is exactly equal to VB star, then it is a zero net present value project, and we should not accept the project. And definitely, if this cost is greater than VB star, the NPV would be negative, and by all means, we should totally avoid this acquisition. Now let's see what we could do to solve for the other variables. What if we wanted to know VB star in terms of NPV and the cost to A to acquire B? That's pretty simple. All we have to do is add cost A to acquire B to both sides, and we get VB star by itself. And what if we wanted to know the cost? Well, we could add it to both sides, and on this other side we would be left with VB star minus NPV, because we would subtract NPV from both sides as well.